Next, we have Padmal, who is PSLab lead developer for FOSSASIA, and Padmal also a PhD student at Uppsala University in Sweden. He's specialized in battery-free sensor networks. Yeah. Okay. Also my friend, yes.
Okay, hello everyone. My name is Padmal, and Anisuru has introduced me already. And I have been with PSLab project since 2017 as a GSOC student. I started with the hardware project and the Android app, and now up until now I'm still with the project, making improvements and making improvements to the apps and the hardware, mostly focusing on the hardware. And in this session I will tell you about the roadmap and where we have been and where we are going in the near future. So what is PSLab? You already know it's a platform, a combination of a hardware and a bunch of software platforms for mainly for science experiments. And the main aim is to provide affordable and accessible lab tools. And the reason is that if you want to buy a single instrument that is quite capable as PSLab, it would be quite expensive, and like an oscilloscope would be over a few hundreds of dollars, but you can buy the PSLab in less than 100. And the core components are mainly hardware and software, and how the ecosystem builds up looks like this. We have the PSLab hardware tightly coupled with the firmware, because without a firmware, hardware is just a brick. And then these two parts, and we have the application layer underneath. We have a Python interface and a desktop app that quite relies on the Python, and then we have a standalone Android app. And what the PSLab can do, it's basically replacing quite a lot of expensive instruments that you need in an electronic lab. We have an oscilloscope, voltmeter. I'm not going into detail about the parameters. It's just we have quite a lot of instruments to work with. And this is some of the user interfaces that we have with the PSLab. We have the Android desktop and the Python interfaces. And now about this one. So we started working on the hardware project in early 2017, and we had this very small board. And the special thing about this board is it had components on both sides, and there were no considerations about mass production done in this one. So Mario, and he was quite interesting about making this into mass productions, and so the first thing we tried was to go for Arduino Uno form factor. The reason why we wanted to choose such an existing form factor is that there are quite a lot of cases and all this stuff that are already built for this Arduino ecosystem platform, so we wanted to just adapt them. And then it turns out it's a quite small form factor, and we cannot put all the components on one side, because if we have all the components on one side, it will reduce the production cost quite a lot, like more than double, I think. So we went to the next size, Arduino Mega. It's about this much in size, and I have some of the old boards with me that we don't. It's like a museum piece, and so we had very fancy stuff like these potentiometers to control the voltage, like a very manual way, and but we managed to get all the things onto one side, so it cuts down the production. And then we improved from that point onwards, and now we are at version 6, with quite a lot of features, making improvements to the first one we had. And mainly, if I point out some of the recent developments that we had in PSLab hardware is that we have USB-C support, even before EU adopted that. And we have an ESP1 Wi-Fi, an SD card, a Bluetooth, a real-time clock, a battery charging capability, so you can use the PSLab as a data logger, and it will run quite a long time. And we improved the signal and power stability using new ICs and new tracing techniques. And regarding the process of the PCB design, we included a bootloader, so you don't need any additional programmer to upload the firmware if there's a new version. And yeah, like I said, we moved the form factor to Arduino Mega, and when I say single layer, it says things on a single side. It's a 4-layer board, and we try to have better low-cost components replacing the old ones, so that it reduces the production cost and it reduces the price of the device. And what we plan for the future, that's the most important thing. And right now we are limited by the parameters provided by the microcontroller, so which is 12-bit 1-channel ADC module. We want to have much higher resolution so that we can have much finer amplitude sampling, and we also need a higher sampling rate so we can support higher frequency signals. And the only way to go is to move to a better microcontroller ecosystem. And right now we are kind of constrained by microchip, which is not open source. Yeah? And so their tool chains are closed, and even the free version introduces lagging to the firmware, like no operations. They just randomly put inside the compile code, so they want us to buy the whole thing. And the best thing is to replace this with some RISC-V or an ARM-based microcontroller. Or yesterday, the team discussed that ESP32 would be a very good candidate, because then we have wireless connectivity already on the board without having to rely on a different pluggable module. And the subversioning means that we will ship only the essential instruments. Like, we can get rid of the simple instruments that are not widely used, or maybe we can have a different version for the whole package. So then it will reduce the cost of the equipment and then more accessible. And we are continuously integrating more sensors to work with PSLab, and it's an ongoing process. And to do this, we need the engagement of the community, and we make our presence in Google Summer of Code, and FOSSASIA has its own program, Code Heat. And with these programs, we have very great individuals coming into the project. Like, we have Anshuman, last year he did a really great job, and then we look forward to doing that. We look forward to continue doing that. And this is how you can connect with us. We have a Jitter channel and also a Telegram channel, and you can get all the details in this website, pslab.io. And that way we hope to have better collaboration and make the PSLab much better and great. Yeah. Thank you. And I'm open to any questions. Yeah. Probably. Yeah. V4 and V5. Maybe you don't see it. There's this potentiometer there. It was coupled with the waveform generator, the sine wave, so you can control the amplitude by just tuning. But we were wondering how many people would use it. It's just an additional bulky component which is not cheap. So we got rid of it, and you can do it in firmware. So with the firmware using the apps, so it's just an improvement. Yeah. And I think, yeah, that's a big main thing, I guess. Yeah, that's the main improvement V4 and V5. Yeah. Rearrangements.
You can give them around, Padmal, maybe.
Yeah, we have another one. We had an NRF connector here, and then we replaced it with UART or Bluetooth. That's another thing that we had.
Well, we can look if you have them there. You can
Okay.
pass them around.
Oh yeah, you can just have a look and see the old boards that are. And there's the new one in there as well. So.
We have few more minutes before we go to the next session. If we have any questions from the audience, we can have it now.
About thank you. So regarding the MCU, right? So we're looking at switching to something else from microchip. But in your opinion, what is the primary reason to do that? Is it the closed source tool chains that's the biggest issue?
No. Well, the main thing is it's not the closed source. It's just that it's a pretty old MCU, and there are better MCUs in the market right now with better capabilities, cheaper and low power consumption. Right now we might not be looking into low power aspect like a principal component, but that will be a thing if we want to go ahead with this data logging thing using battery powered. Yeah. So and altogether it's quite old. So
yeah,
we need to
yeah, I agree. I sort of wanted to lift that because the thing is, the tool chains that we use right now in firmware development are actually are no closed source parts of our tool chain right now.
The compiler.
The compiler is not closed source. Like that's it's GPL version 2. It's just really difficult to build.
Yeah, but yeah, there were some discussions previously where some people, it's not official, but they said because it's a free version, they include no ops in between.
I don't think that's true. I think that's a myth. So what they do is in the free version, you can't use the highest optimization levels. So you can't use O3, you can't use OS for speed and size optimization respectively. But we can use O2, and that's what we're using in the production builds, and it's fast enough for us. So that's
maybe that's why they're thinking they're putting knobs, because it could be actually the optimization they're trying to do. Maybe they see it in a different way.
I mean, yeah, okay, sure.
Yeah.
I don't think they're intentionally making it like slower, but yeah, they're not letting free users.
Faster,
yeah. Yeah. But like, so previously, right? We used to use PSLab X, which is Microchip's IDE, for development, because that's yeah, it's kind of tricky to build for PIC devices using alternative tool chains. But like that's one of the things that I'm actually pretty happy with in the firmware development, that we switched to CMake. We switched to MC boot flash for flashing. So yeah, all things considered, I think that part is like that's the least of the problems with the PIC. It's more like you said, it's getting quite old.
I think it's older than 2017, so it's maybe more than 10 years old.
Yep. Okay. Yeah. Thanks.
It does seem to be out of stock in at least a few of the countries that I've checked.
Yeah. Okay. So we're about to launch a new shop. Yeah.
You can buy them from out here, right? The front desk.
Okay. Thank you very much, Padmal.